Hey guys, now we're going to talk about random variables in statistical and mathematical uses, and here are the contents. To start with, we have to know what is random variable. In probability and statistics, a random variable is a variable whose value is subject to variations due to chance. If you think this definition is too hard to understand, I will tell you random variable is a set of possible values from a random experiment. Two main points: independent experiments and a set of values. Let's have a look at example. If you toss a fair coin for several times, you will know there are two outcomes, heads up or tails up. Let's take heads up for 1 in one try and tails up for 0. We now have a typical random variable x to denote the number, and x may equals to 1 or 0. And now we have two more examples. If two fire dice are cast and let x to be the total number of spots on upsides, we know x can be any number from 2 to 12. We call x a random variable. And in the next example, a candy bar with a 20.4 gram label weight is selected at random from a production line and is weighed. We can also find a random variable, which is the weight of one candy bar. We cannot tell all the possible values of x, but it is still a random variable. In order to study the random variables, we also have functions called distribution functions. Let's have a look at the definition. It says the function refers to the cumulative probability of x. And the properties, like the value of function is strictly between 0 and 1, like the function is positively related to x, like the value rises from 0 to 1, and some other useful properties. Now we come to the properties of random variables. I will introduce two main properties to you: uncertainty and classification. Uncertainty is to tell us, although the values are uncertain, but what we can make sure is that those values have certain probability to fall in a certain range. For example, the graph on the right gives us what a random variable following normal distribution should be like. It is ideal, but in reality, we won't get this perfect curve. Now we're going to talk about the classification. There are two kinds of random variables: discrete variables and continuous variables. The difference is whether the variable can take unlimited values or not. The discrete variables are those which could take unlimited values between two specific values. According to this classification, the distributions are also divided into discrete distributions and continuous distributions. Some useful discrete distributions are binomial distributions, Poisson distributions, and Bernoulli distributions. Some useful continuous distributions are normal distributions, chi-square distributions, gamma distributions, uniform distributions, and t-distributions. When we are going to calculate the probability of random variables, we have to use this PMF, PDF, or CDF. Here is the difference of the three. PMF is used in discrete distributions and PDF is used in continuous ones. The integral of PMF and PDF is CDF, also the cumulative probability function. We also use small f to imply PMF and PDF and capital F to CDF. We have some mathematical properties here, and a graph of capital Fx is like this. Now let's have a look at examples. The first example is about binomial distributions. After reading the question, we see 0.8 is the probability and 5 is the number of trials. The random variable in this question is the number of success, and it can be 1 to 5. The second question is Poisson distribution, a practical example on Geiger counter. We see the random variable here is the number of alpha particles emitted by barium-133 in 0.1 seconds. and this is the first step to handle with the problem. The other kind of random variable is continuous variable. Continuous variable can take on any values in a certain interval. We cannot list all its values. It has some properties based on mathematics, and we are not going to talk about it today. I also have two examples for you. The first is the standard uniform distribution. It is a special case of uniform distribution, and also the simplest distribution as we can see from the graph. The second one is normal distribution, which is the mostly used distribution. The graph of standard normal distribution perfectly reflected what continuous variables are like. Now we come to exercise part. There are 5 balls in a box named 1, 2, 3, 4, 5. We take 3 balls independently, and let x be the max number of the 3 balls. Obviously, x is the random variable, and we can figure out the probability of each value of x. The solution is also here on screen. The second example is about continuous variables. There would be a bus arriving at the stop every 5 minutes. If a passenger can arrive at the stop at any time, and he will get angry when his waiting time exceeds 3 minutes. The random variable here is the passenger's waiting time, and we can figure out the probability of x by properties of uniform distributions. Okay, do you know more about random variables now? Hope this video could help you. Thank you for watching. Bye.